So I need to create something on the computer to hold some information for my job. It needs to hold the contact info for each employee and all of the projects they are assigned. I'm not sure how to do this. How do I put information from each part together so I can find it?
Well, it sounds like you need to create a database. A database is an organized collection of data ideal for storing and retrieving information.
Which means...
It's a bunch of tables that hold all of your information, but they are linked, so you don't get a lot of duplicate data. This makes it easier to find your information later because you can do a search for the data you want instead of seeing everything at once.
Okay, you convinced me. I need one of those database things. But how am I supposed to make one of them? It sounds really difficult.
Actually, the most difficult part is figuring out where the data needs to go. But you can make this step a lot easier by creating a diagram beforehand.
What kind of diagram are we talking about?
I would recommend an ERD, that is, an entity relationship diagram. It separates the information you need for each table and shows how the tables link together. I like it because it's a great way to see the overall design of a database.
Sounds good. Where do we start?
Well, first you need to know some basic terminology used by professionals when they are talking about databases and diagrams. Some of the common terms used are entities, attributes, relationships, and cardinality.
Cardinality? I thought that was a baseball team. You're going to have to explain those a little bit more.
I will, but first let's figure out all of the things I need to teach you. Before we start working on your database for work, I'm going to walk you through a similar database for education. I will explain what an ER diagram is, as well as the parts and purpose of it. I will also explain how you can apply business rules in the design of an ER diagram. Then we will go back and apply this new knowledge to your business situation.
I guess I should pay attention.
To start off, an entity relationship diagram, or ERD, is a graphical representation of the data requirements for a database.
Meaning?
Meaning that it takes all of the parts of a database and puts them in a box and line form. There are 5 major parts to an ERD: entities, attributes, primary keys, relationships, and cardinality.
Yeah, I think you mentioned those.
Those parts will be used to create the ERD. Then the diagram acts like blueprints for a building. You simply take the parts of the diagram and turn them into parts of the database. The final diagram should look kind of like this. Now to explain those parts. First, we have entities. An entity represents a person, place, or thing you want to track in a database. In this example, student. This will become a table in the database.
So you're saying a student is an entity?
Kind of. Student is more of a container which will hold many students. Entity basically means that all of the things that are like a student will be grouped together under student.
So there will be this table of students?
Yes. Each occurrence of this entity is an entity instance. This will become each record or row in a table.
Oh, so this is like each individual student. A single student is an instance of the entity student.
Yeah, you've got the idea. Now we have attributes. An attribute describes various characteristics about an individual entity. These will become the columns in the table.
Wait, it does what?
Well, it tells us more about the entities. Each of those students now has a first name. The first name is an attribute because it tells us more about each instance of student.
So each individual student has a first name. Got it.
Yes, but it is important to note that these attributes can be unique to each student, but they don't have to be, meaning that each student can have their own name, but if there are 2 students with the same first name, it is still okay.
That makes sense.
Good, because that brings us to the next part, primary keys. A primary key is an attribute or group of attributes that uniquely identifies an instance of the entity.
Slow down. It's an attribute that identifies what?
Remember how I said that attributes don't have to be unique to each student? Well, a primary key is like a special attribute that must be unique. A primary key will uniquely identify each instance, or make it so that no 2 rows will have the same value for that attribute.
I think I understand. So at first the students only had first names, but if 2 of them had the same first name, it would be confusing and they might get mixed up. But now you added student ID, which means that no 2 students have the same number.
Yeah, you've got the idea. Keep in mind that sometimes you need more than one attribute to make each instance unique. In those cases, you need to use a composite key, but we'll explain that one more when we get to business rules.
Sometimes you need a composite key instead of a primary key. Got it.
All right, now that each of our students has their own unique student ID, we can start forming relationships.
Relationships? Are they going to hold hands?
Not that kind of relationship. A relationship describes how one or more entities interact with each other. Usually this is described with a verb. We're going to create a link between the entity student and the entity phone number, so that when we create the database, we can easily find the contact information for each student instead of filtering through rows of numbers.
Sounds beneficial. How do we do this exactly?
In the diagram we're working with now, we are going to show the association between student and phone number using a verb. A student has a phone number.
Seems pretty straightforward. Just draw a line between entities showing they are connected through a relationship.
Yes. However, relationships can be between two instances of entities, or maybe a lot of instances, or maybe you don't even need an instance. This complex idea is explained through cardinality.
Oh, so we're not going to a sporting event?
Sorry to disappoint. Moving on. Cardinality is the count of instances that are allowed or are necessary between entity relationships.
Okay, that one is a little hard to grasp.
Let me simplify then. Remember how entities will be tables, and an instance of the entity is a row in the table? Cardinality just tells us how many rows we need from one table before we can link it to another table.
So
let's go back to our student phone number relationship. A student can have 0, 1, or multiple phone numbers, right? But each phone number must belong to a student.
yeah, I can see why you wouldn't want to have a phone number in the database unless it belongs to a student.
Exactly. Now, cardinality is broken down into two parts, minimum and maximum. Minimum cardinality represents the minimum number of instances that are required in the relationship, and maximum cardinality represents the maximum number of instances that are allowed.
Wait, so the types of cardinality are what?
Minimum tells us the fewest number of rows we need for a relationship, and maximum tells us we cannot exceed a certain number of rows in our relationship. An easy way to represent cardinality on a diagram is through crow's foot notation.
Crow's foot? You mean like the bird?
It kind of looks like its foot at least. There are 4 different ways to represent cardinality using crow's foot notation. 1 mandatory means that you must have at least one and only one instance. Many mandatory means that you must have at least one, but you can have several instances. 1 optional means that you don't have to have an instance, but if you do, you can only have one. Many optional means that you don't have to have an instance, but if you do, there's not a limit on how many instances you can have.
So the mandatory versus optional refers to the minimum, and the 1 versus many refers to the maximum?
That's right. Now that you know some of the terminology and parts of an ERD, let's see if we can combine them with business rules to see how they influence the diagram. A student can have 0, 1, or several telephone numbers. They may or may not have a telephone number. How to apply this to an ERD. Create a student entity and a separate phone entity. Then create a one-to-many relationship from the student to phone number. This means that one student can have many phone numbers. Then show optional versus mandatory. It is optional for a student to have a phone number, however, it is mandatory that a phone number is connected to a student. Student A graduates from a university, moves out of the country, and cancels her phone service. A year later, student B moves from out of state to that same university. When she signs up for a new phone service, she is assigned the same phone number that student A had canceled. Now there are 2 different students with the same phone number. How to apply this to an ERD. As a rule, the primary key must be unique and can only appear once in an entity. If the phone number alone is used as the primary key, it can only be used once, and you will get an error if you try to use it for another student. If you use the student ID alone as the primary key, you will only be able to have one phone number per student. To solve this issue, you will need to use a composite primary key. This uses a combination of student ID and phone number to create a unique identifier. At any given time, a student can either be an undergraduate student or a graduate student. They can also be at one time an undergraduate student and then become a graduate student. Depending on the type of student they are, we need to collect specific information that applies only to that type of student. How to apply this to an ERD? We need to create 3 separate entities: students, undergraduate, and graduate. The student entity will hold the information that is common to both types of students, such as names, addresses, etc. The undergraduate entity will hold the data that is only applicable to undergraduate students, such as the high school they graduated from and their high school GPA. The graduate entity will hold the information that is only applicable to the graduate students, such as the undergraduate university, major, and undergraduate GPA. This will allow you to track information that is specific to a type of student without taking up extra space for the students this rule doesn't apply to. One student can take many courses, and at the same time, one course can be taken by many students. This is determined during registration. How to apply this to an ERD? You need to create a many-to-many relationship. If you were to try and express a many-to-many relationship using only 2 tables, you would get an error message. This is impossible. The way to properly create a many-to-many relationship is by using a bridge table, creating a one-to-many relationship between each main table and the bridge table. When we introduce a bridge table, in this case, the registration table, we can combine the data from both tables while still keeping it organized and uniquely identified. Now let's see if you can apply this knowledge to your business situation.
I think I can do this. I will create entities for each table I need. Then I will write in all of the attributes I need for each entity. Then I will use unique identifiers for primary keys, which will allow me to form relationships. I will use crow's foot notation to show cardinality, and then I will have an excellent diagram. After that, how hard could it be to build a database?
Wow, it looks like you've got the right idea. Now let's see how your finished ERD will look.